Thank you.
Okay, so it's time to start, and welcome everyone. My name is Tobias.
And my name is Martin.
And we are from Omega Point Gothenburg. We do security reviews and penetration tests. And we also work as developers, writing and maintaining code. And we also help teams with application security.
Yep. So our thinking here today is a result of years of developing applications as well as performing security reviews.
Yes, and in the presentation we will talk about how automated tests can help us build secure APIs. And the code that we will show is available at GitHub. It will be the demos will be in .NET C#, but the concepts that we present are valid for any framework, and we also have a repo in Java.
Yeah. So we rarely see teams writing tests for security, and we believe that's a missed opportunity. It's both quite simple and very powerful to write tests that verify that your defenses are working correctly. And we also strongly believe that tests can help you better understand your domain and its boundaries. And today we'll talk about how to choose which test to write, and we'll also show you a bit of code of what that could look like.
Yeah, but first we need to talk about why pen tests tend to find the same vulnerabilities over and over again.
Yeah, so this is the OWASP top 10 list for APIs. We know that it's from 2019, and it's still very accurate. It matches our experiences, I think, quite well. API security issues and how to deal with them has been known for several years.
And there are, of course, many reasons for that. One could be not enough budget or team resources to deal with legacy code, which might be hard to address. But we often find that vulnerabilities originate from unclear, non-functional requirements and lack of tests with security in mind. So if these issues was found during development or testing, we would simply call them bugs, not the vulnerabilities.
Yep. I think it would be great if we could catch security bugs just as early as any other bugs before the application has been deployed into production.
Yeah, it sure would. So here we have a pen test report where we have findings represented by the red, yellow, and green lines over there. And we address them or refine them to bugs in the backlog. But even if we represent them as bugs, there is an important difference between functional bugs and those security bugs. Functional bugs, they will often be discovered by users if they end up in production, while security bugs, they won't be discovered by users, and attackers who exploit them, they will probably not report them as well, and probably not be detected. So the vulnerabilities will stay open for a long time.
Yeah, so if we think about vulnerabilities as normal bugs, then security is just another non-functional requirement and should be part of your quality assurance process with backlog refinement, prioritizations, and all the other things that the teams do. So in this case, the team has tagged security bugs, and we can see that the team has prioritized the two most critical findings for the next release.
Yeah, security and quality go hand in hand, but how can we as the developers assert high quality in the applications we build?
Yeah, so our industry has some very well-established patterns and practices for quality assurance, and one of them is test-driven development. And we'll try to show how to apply TDD to application security to help find those security bugs during development and not after deployment to production.
Yeah, so note that we are not saying test first, but we are saying test before deploy to production.
That sounds completely obvious and simple, but we do find that while most teams do implement automated tests these days, we rarely see tests aimed at security. So well-written test cases can help us identify the boundaries of our functionality. And if we find that we have a hard time writing good, clean tests for security, then I think there's a high probability that we have problems with understanding the domain that we're working in.
Yeah, or put in another way, you can't secure what you don't understand, and the tests will help you understand and define exactly how a function should work, not just the happy case.
Yep.
And so now let us look at how we can apply TDD thinking to our application security.
Yep. So a little bit of context. We're thinking about, for this presentation, we will focus on APIs, obviously. So picture a system that consists of a set of APIs, and we have a set of callers that is consuming those APIs. Some are ordinary users, some are high privileged administrators, and some are services, perhaps other APIs that are talking to us. And we need to restrict access to these APIs in some way so that each caller should get at the least amount of access possible.
Yeah, so if we look at basic requirements for this context, then we could express this in the following way. Callers should be able to consume the APIs. This would meet any functional requirement, and we would typically verify this during testing and development. And when it works, all tests are green, we can deploy to production, right?
Yeah, well, we note that the requirement here is not perfectly clear. It allows for the ordinary user to access functionality intended for administrators and services. And instead, I think that we could express this requirement as the caller should only be able to consume the APIs and functionality needed. And we know that this sounds easy and completely obvious, but we often find that teams do not express negative requirements like this. And it is essential for security that we identify boundaries in our requirements.
Yeah, because this is what attackers do. They try to misuse the functionality that we provide and break out of boundaries and execution contexts. But it's hard for teams to switch to the mindset of an attacker and try to misuse their own system. It's more natural for developers to think in terms of non-functional requirements and domain rules. So if we do that, we can limit attack vectors without being experts on attacks. And so how can we verify this only?
Yeah, so I think that for this, we typically use negative test cases. The users should not be able to consume API 3. That will assert that we can only reach API 1 and 2. I think that another good example of these negative test cases is tenancy isolation. Perhaps the user should only be able to access data that belongs to her organization. We rarely find requirements or test cases for tenancy isolation, but most teams that we talk to and work with, they identify this threat among their top concerns. And it's also the #1 on the OWASP top 10 list for APIs.
Yeah, so let's look at what we mean with a secure API. And you can, of course, implement a secure API in many ways, but you need to handle these 6 steps in one way or the other for all requests.
Yeah, so this is typically roughly what we are looking for when we review code from a security perspective. And based on experience, we believe that you do need to address all of these steps in order to get a strong solution.
Yeah, so in step 1, we validate that it is traffic meant for us, that it is a valid request, valid HTTP. And we should get this from the web server and infrastructure protection. Step 2, we need to validate the token for API. That often means a JSON web token. And this we should do by using a well-established library or component. We should not implement this on ourselves. So step 1 and 2 should only be configuration and support from the web framework we use, not our own custom application code. And then for step 3, we transform the access token to permissions. We need some mechanism to go from authentication metadata in the token represented by claims to rich fine-grained permission model.
Yeah. And then we're down to the domain logic, and in step 4 we will validate the data in the request that it is semantically correct. And in step 5 we verify that the caller can perform the operation requested.
Yeah, and we should note that this is a model, and the order between step 4 and 5 might be different in different implementations. We should do basic authentication or authorization at the routing level, and this could be done in a gateway in front of us, or in the API using a controller if you're using .NET. And but we should also note that this does not replace any token validation in the API or authorization in the domain layer. For a strong solution, we need to build with multiple defense layers. And the core business domain layer should not assume that other layers has done security like input validation or authorization.
Yeah. So in the final step 5, we verify that the caller has access to the actual data requested. That's a very common mistake to miss, which lets us break out of tenancy isolation.
Yeah, so how do we find out what kind of tests we need?
Yeah, so for that, a good place to start is, of course, the OWASP ASVS, but we also like the OWASP Web Security Testing Guide. And we think that these two resources can be used as a sort of security testing baseline, and that will help us identify test categories. And for this demo, we've listed the most relevant ones for us. For your application, you might identify additional categories. We note, for example, that we do not have compliance and regulations part of this list. Performance might be higher for your application.
Yeah, so let's look at how we can use this. And here we have the API, and we have the test categories. And in the demo, we will add tests to verify that we cover these categories. We will have system tests that run against the instance of our API, and we will have unit tests where all integrations are mocked. And we will start with the system tests. And they will concern step 1 and 2 in our API model, and test categories: authentication, basic parts of authorization, and transport security. So we will start by looking at the API.
Let's drop down to some
it's
code.
Time for demo.
Time for demo, yep. So I've got an API running on my machine here. It's running on localhost. I got 5,000. And please note that it's 2023. I'm running HTTPS only. There's no need for HTTP anymore, I think, even for local development. Okay. Yeah, please make an effort.
Yeah, so we can look at the controller.
Yeah, let's look at the controller. So this is a standard controller in C#.NET. We notice that, is that big enough? Works? Yeah, great. So the base route for the controller is API/products. I've got an implementation of a single endpoint. The endpoint takes a string from the user, part of the route. It passes that ID to a repository abstraction. And if we find a database entity, we map that to a domain object, and we return a 200 OK with the product. So when we review code, this can be a lot more complex than this, obviously. There can be a lot of things going on in the controller, but this is the essence that we want to lift out, and typically what we're looking for as well. It is obviously a weak implementation. There are some pretty glaring vulnerabilities here. For example, simply returning the domain object back to the caller. When we are leaving a trust boundary like this for an API, we are typically looking for dedicated data contracts to represent the data. We can also see that the input string here, user input, is passed directly to the repository layer. That might be fine. The repository implementation could correctly encode this data, use parameterized queries for SQL statements, etc. But at this point, we simply do not know.
No. And injection is common. So.
Yeah,
Yep.
yeah. I know where my money is for that. So, and also, perhaps the most obvious one, there's a complete lack of access control here. Perhaps there's 99 other endpoints that are perfectly implemented with full access control, and we've just something gone wrong for this endpoint, and it's simply missing.
Yeah, and before we move on, we really want to point out that injection is mitigated with correct output encoding for the given context, and input validation will only limit attack vectors, but we should use both when we build strong, safe implementation of APIs. And also, we could also note that there were a lot of OWASP top 10 things here. One is excessive data exposure, returning too much. We had injection, and we have different types of broken authorization here as well. And yeah, so we can look at some system tests. This.
Yeah. So we have a set of system tests that we wrote for this. Perhaps we should start by
we can
running them.
Start running them. Yeah.
Let's see how it goes.
Yeah. And
yeah.
Well,
not great, not terrible.
No, some red, some green.
Yeah.
We can start looking at the health tests.
Yeah. So let's have a look at the health tests. So a very important part of any API is availability. What we've done here is that in addition to the products endpoint, we have two endpoints for availability, liveness and readiness. And the first system test says that when I have an anonymous HTTP request and request the liveness endpoint, I should get a 204 no content back. If I do have an anonymous client and try the readiness endpoint, I expect a 401 unauthorized back. And if I am authenticated, I expect the readiness endpoint to return a 200 OK, the version number of the software that I'm running, and some information about the .NET runtime that my software is running on top of.
Yeah, and here, since we are authenticated in this readiness endpoint, we can do deeper system checks, like accessing a database and things like that.
So we often see that example for readiness endpoint. You check that the database is available. Perhaps you query downstream integrations that you use. And we often see quite a lot of information being passed back to the caller as a result of that. And there is absolutely no need to expose that to an anonymous client.
No, because that is quite a common mistake as well, that you have an anonymous live that starts out simple as a ping endpoint, and then it grows and returns more and more. And maybe you could use this to do a denial of service of the system.
Yep. Then there's a system test that when we have an invalid token, we expect that the endpoint should return a 401 unauthorized. Good examples of invalid tokens is perhaps a previously valid access token, but that one that has expired. Another good example is an ID token. That one we see quite often, I would say. ID tokens should never be useful for API calls.
The API should only accept access tokens. And another test case would be invalid signatures, like the ALG none issue that is quite common, depending on the framework you're working with.
And then there's a set of system tests that I'm not running while I'm working localhost, because they require a reverse proxy in front of them. The first one is that I'm not accepting traffic to HTTP. The next one is that the TLS version that I'm requiring is version 1.3. And the final one is that all endpoints should return a small set of security headers. OWASP guidelines recommends that we do return a set of security headers even if you do write an API. They are not that many, and they are quite easy to implement. So
Yeah, so just add them.
Yeah, that's a good
Yeah.
recommendation, I think.
And with that we can look at the error tests.
Yeah, right. So we have a system test that when an endpoint throws an exception, we expect a 500 and an empty result with no additional information. And for a high quality API, it can be quite tricky to make it throw an exception. So what we typically do is that we add an error controller whose sole purpose is to throw an exception. And that makes it possible to write a simple system test like that. Please remember to require authentication.
Yeah. And verify that you don't leak any data, because that's quite common as well, that you, when error occurs, you want to tell the developer what went wrong. And then you might give them connection strings and stack traces and a lot of information. So be careful there.
The correct way to figure out why we throw exception is probably look at logs and not return data back to the user.
No. So we can look at the products test, the system test for the product controller.
Right. So we have 3 tests, simple system tests for the products endpoint. When I am authenticated and have the correct scope and query for the product, I expect a 200 OK back. When anonymous and querying for the same product, I expect a 401 unauthorized back. And when correctly authenticated but with the wrong scope, I expect a rescope here. I expect a 403 forbidden back.
So we can note here that the happy case works, but not the negative test cases. And this shows the importance of the negative test cases, because without them, we might have deployed this to production with an open endpoint.
Developers rarely test their, or at least manually test their APIs without authentication, because things.
Yeah, so we can go back to the slides. And the test that we have shown is has covered the test categories, authentication, basic parts of authorization, and transport security. You could, of course, argue that validating a JSON Web Token isn't authentication, it's part of authorization. But for this demo, it really doesn't matter to distinguish between the two. So we can, let's move on and look at the unit tests.
Yep.
And the first set of unit tests are for the controller and for the responsibilities that the controller has, which is to do basic input validation and handle the result and return the data, and also the correct response codes. So we connect this to the test categories, the data confidentiality and the integrity. And now we will have a look at the test for the product controller.
Yeah. So let's close the system test and look at the unit test for the products controller. Maybe start by running them again.
Yeah, that is good. We see.
Not so good, but then we know that we have a weak implementation.
Yeah.
So let's look at what we have chosen to write.
We can note that the happy case works. It always works.
Yep.
Works. It's happy.
Yeah. So the first test is that when we set up the controller for success, I expect an OK object result back from the controller. For data not found, I expect the 404 not found results. And when I set up the controller for no access to operation, I expect the forbid result back, maps to 403. And when I have no access to the data, we can typically choose between 2 valid HTTP status codes. 403 forbidden, which is correct. I mean, there's data there, but I'm not allowed to use it. Or the 404 if I don't want to reveal the fact that there's data there. And for this demo, we've selected the not found 404 result. And then there's a test that verifies that when I try a few samples of invalid product IDs, I would expect a 400 bad request object result back. And then finally, when I do get a result back, I expect to get a dedicated data contract back and not the full domain object. And most of that fails. So.
Yep. And we will address all these red tests later when we go back to the slides and look at the next categories of tests. And they will concern step 3, where we transform from the JSON Web Token to permissions. And they will verify the permission model that we have for this demo API, which is that you should only have access to products for a given market. So let's start by looking at the permission service.
Yeah, so if we look at the permission service, so
interface.
Many frameworks and .NET in particular kind of leads us down a path where we have a principal object, a user object injected into the request pipeline, and that user has a set of claims in it, represented by a dictionary, string, value, key pair thing, and that's the object that we can query when we to do our access control on top of. It doesn't have to be like that. In this code, we've instead selected to declare a permission interface that contains at the top 4 properties that reveal the identity that we pick up from the incoming access token regarding the user. And then here, first a set of simple Boolean properties, if I can read products, and a simple method that figures out if I can read this particular product. And we think that makes for a much better developer experience. It's strongly typed. You will get IntelliSense in your IDE and don't have to work with these key value strings. And also lends itself perfectly for writing unit tests.
Yeah, and we should note that this often involves a service or database lookup, where we use those identity properties from the token to look up the permission set and maybe make authorization decisions like you can read products. And this gives us a centralized pattern for the permissions and the access control. And it can, of course, be externalized using a service that we share between APIs or things like Open Policy Agent and so on. But we use an in-memory implementation in our demo, and that's often fine as well. So
could be.
Yeah. So should we run the tests?
Yeah. So let's look at those tests and start by running them. See what we got. Yeah.
All green.
Strong implementation for once. So let's have a look at the test that we selected for the permission service. First, it is that the unauthenticated user, represented here by the claims that we would expect to find in the token, should properly populate the identity properties of the permission service. The second one is that unauthenticated users with the correct scope should be able to read products. Next test is that unauthenticated users should be able to read products from my market. And with that done, we can move to the negative test cases, the cases that identify and declare the boundaries of my functionality. The first and obvious one, perhaps, is that if I have an anonymous user that do not have any claims in the token,
so this is,
then I expect an empty identity, and I expect not to be able to read products. And the next one is that an authenticated user, but with the wrong scope, I would expect not to be able to read products. The next one is that an authenticated user, correctly authenticated, should not be able to read products that's not part of my market. And I think that those kinds of tests are hugely valuable and nicely documents and summarize what we would expect from the permission model.
In particular, this last one, this is sort of multi-tenancy and EDOR and things like that. That's a very, very common problem in APIs.
Yeah. And this kind of pattern of declaring a central permission service or policy service like that enables us to write these kinds of tests in one place. It can be quite tricky otherwise to find this documentation across your code.
Yeah. So all is green, and we can go back to the slides and the final test categories. And the final set of tests is for the product domain or service layer. That's step 4, 5, and 6 in our API model. And now we will address the remaining red tests that we have seen, and so that we can assert that we have well-defined boundaries and cannot misuse the API. And we will cover all test categories except authentication and transport security. And we will now start fixing the red tests and weaknesses in our controller. So we can go back to the controller.
Yeah, great.
And we will start with limit attack vectors for injection by introducing input validation.
Yeah, so let's try a naive approach here and simply start with the fact that I'm not accepting null data. No, I will not accept an ID that's too long, and I will not accept any input data that is not a letter or digit like that. So if that happens, then I will return a no, I will not redirect.
No.
Return.
Bad request.
Bad request is better. Yeah,
for.
thank you. That's an invalid ID.
Yeah.
Like that, I think.
Yeah, looks good. Let's try that.
Yeah.
Run the controller test again.
Restart the API. Let's run the controller test.
There were a lot of red tests there, if you remember. So now let's see if we've improved the code, anything. Yeah. The input validation tests are green. So actually this simple code, it captures the requirement we have for the product's API. But this kind of code is, it's kind of, if there are a lot of endpoints, it's easy to do mistakes with this kind of code. So we want to use a stronger pattern to limit the risk for that. And we can use a pattern from domain-driven design or domain-driven security, where we introduce domain primitives. So because our product ID isn't a string that can contain any character, and it should always be treated like a product ID.
Yeah. So we have a domain primitive for a product ID implemented. It's not big. As you can see, I got the same validation here that I just implemented in the controller. And the constructor here will assert that input data conforms to that semantic validation. And if it does not, it will throw an exception. So it's actually not possible for me to create an instance of this domain primitive without also conforming to our rules for what the product ID would look like.
And we have some unit tests for this, of course,
sure.
because it's very easy to write tests around a class like this.
Such domain primitives lend themselves very nicely to unit testing. Of course, we've got the happy case, 2 valid IDs here that should the constructor should accept and should work properly. And then we have, again, the negative test cases, verifying the boundaries of our functionality. An obvious invalid ID that contains spaces, but then I want to try some injection strings. And what we often do is that we resort to a resource. There's a lot of resource on the internet for injection strings. We like the GitHub repository big list of naughty strings. They maintain a list of injection strings, so that we don't have to figure those out ourselves. And I've just selected a few of them that I thought was relevant. That repository contains a lot more information. For example, some tricky names that tends to crash systems. That's quite fun as well.
Good test data.
Yeah. So what we do here is that we try all of these and see if and we expect in our test that the constructor would throw an exception.
Yeah. So we can apply this and we can go back to the controller.
Yeah. So instead of this code, then I can simply use my domain primitive. So product ID is valid like that. And I would then typically quickly move to the product ID domain primitive in my code. Product ID. Like that, I think, yeah.
Yeah, so that's good.
Yeah.
And we should note that using domain primitives is more than just input validation, but we will not cover state-changing functions and domain logic for that today. And that the same reasoning applies to other domain primitives like an address or a product name or something like that. So now let's look at authorization. And we could, of course, add code for fine-grained authorization in the controller, like we did with the input validation. But this does not scale well when the API grows in features and we have more and more endpoints. And we don't want that kind of logic here in the application layer. So we will introduce a product service.
Yep. So we've got a product service here. It's a simple interface. It's a get by ID method. As you can see, we're only working with domain objects now. So no strings, only domain objects from our domain. We will return a product and an indication of the results. So let's have a look at the implementation. And now we can use the permission service that I showed earlier. So instead of working with string claims from the user principal, we can instead work with the permission service. So if this calling user cannot read products, then we would return a null product and a no access to operation indication. And if we do find the product in the repository, we will check if this user can read this particular product. And if she cannot, we will indicate that this is no access to data. And otherwise, we are all good. We return a success and the actual domain object.
Yeah, and if we go up again, to the beginning, we want to note that the order here is important. Because we want to abort invalid requests early and without consuming system resources or doing complex domain logic. So we should always do input validation, which we can see from the product ID, and access to the operation as early as possible before any domain logic.
Yeah. So if we do not have access to the operation, we will not even make the call to the database.
No. Because verifying access to data might be really complex. You might need to work out the relationship between objects and so on, maybe like a search function. So that will be the last thing you can do here before returning the object. And also note that we do logging for monitoring and accountability. So that is also important to verify in unit tests that you log when you should.
Yeah. And we note that we only log with domain objects as well.
Yeah, yep. And also that we note that we read the data.
Yeah, For some systems, accessing data can be the most sensitive operation there is. So.
Yeah, so let's go back to the controller and use this service.
Yeah, right. So let's get rid of that vulnerable code, and using our new service, we can declare the product, a data result, and let's call our service get by ID, product ID, like that. Yeah, and I think that with that in mind, we can now switch on the data result. And let's start with the easiest case, that is that we've got a success. In that case, I would like to return an OK result with the product. The next obvious result is the not found part. I would return a 404 not found. And then we had the no access to the operation, typically a 403 forbid. And then we had the no access to data, and we selected the 404, I think.
Yeah, that's right. Correct.
Yeah. Oh, semicolon. Yeah. Thank you. And in all other cases, I will simply throw my hands in the air, give up, and throw an exception. And my exception of choice is an invalid operation exception.
Yeah, because this really is an exception.
Yeah.
We should never get here.
So, looking good, I think.
Yeah, I think so. It looks good. And we can try and run the controller test
Yeah.
again and see if we have improved anything with all this.
Restart the API.
Let's hope so.
Have a look.
Yeah. And
Yeah,
almost.
pretty good.
Yeah.
We've got one failing test, and that's the test that would assert that we are using a dedicated data contract, which I am not. I'm still returning the full domain object. So let's change that and use the excellent auto mapper to map that domain object to a product data contract like that. So let's have a look at the data contract itself to see what that would look like. So this is typically something, what we're looking for in our case. The data contract only consists of 2 elements. I intend to return the ID and the name of the product. Of course, the domain object can contain a lot more information and a lot of sensitive information that should never leave our trust boundary.
Yeah. So this is the pattern for mitigating the excessive data exposure vulnerability.
Yeah. So let's restart that API and let's have a go again. See if we're good. Yeah?
Yeah,
Nice.
so all is green there. So let's run the system testing, or we can run all the unit tests first.
Yeah, we could. We could.
How we are, what the states. Yeah.
So they're all green if you noticed. All of those.
Yeah, great.
Hard to notice.
And now we can run the system test again, but we had some red there from before. Let's see how that goes. And almost. We have 3 left there. And if we look at the 2 in the help controller, they are red because the authorization we added, it was just for the product service and the product controllers. And unfortunately, .NET does not have a secure default as part of their templates. To have a strong solution, we need a mandatory pattern, deny by default, and forcing authentication and basic authorization maybe for all requests. In other frameworks like Java Spring Security, we get this by default, but in .NET we need to add some code.
Yeah, right. So this is the program that hosts our API. This is what it looks like in .NET 7. And as you can see, I've added authorization, but as you said, the default is unfortunately to allow anonymous calls. We need to change that default.
And the default is there to ensure that the happy case will work from the beginning.
Yeah. So this is what it looks like. I set a default policy as well as the fallback policy to require an authenticated user and use JVT bearer defaults. And
so now we will require the bearer schema here for authentication for all incoming requests. So let's try again.
Try those system tests again,
And now the happy case doesn't work anymore. So the liveness there, now we need to open up that endpoint because so now we can decorate that with an allow anonymous attribute. So we have this default by deny pattern.
So right now, so this now requires authentication, which was what we wanted for the liveness. I need to decorate that with allow anonymous. And now perhaps finally.
Let's run again.
Right.
Yeah, so we're all green and almost done. But for a strong implementation according to best practices and OWASP ASVS, we should also apply authorization at the routing level, not just at the resource level. And we can do this with support from the web framework in the controller, or we could do this in a gateway in front of our API, or both. With .NET, we would use policies and attributes. With the Java Spring Security, we would use pre-authorized tags. So let's add those policies.
So I just added 2 policies, and this is the name of the policy. And what it does is that it requires that the scope products read is present in the token. So if I go to the product controller, I can now decorate this endpoint with an authorized attribute and say that I want that policy in particular. Oh, not with double.
Yeah. So this gives us a way to abort the request really early before we enter the controller.
Yeah. So the .NET ASP.NET pipeline would now, if the incoming access token does not contain a price-free scope, I will not even get into this code. So.
Yeah, and we add this for defense in depth. It doesn't replace any authorization in the domain or service layer. And this is it.
Yeah, pretty good.
Yeah,
I like it.
Yeah, it's we could of course use more features in the web framework or the language to get maybe fewer lines of code and so on. But this is sort of a clean implementation that demonstrates the important security concepts that we want to show here for an API. And we could note a few more things, that we use explicit routing. We assert this only accepted a GET request. And that we get the data from the router, so we don't have any mass assignment issues.
Yeah.
And so all is green, and we can go back to the slides.
Yep.
And in this demo, we have showed that with a reasonable effort, we can cover basic parts of security testing and apply TDD to application security. And that we meet those security requirements and address most of the issues on the OWASP top 10 list.
Yeah, and we think that none of the tests that we have shown here are particularly hard to write. They might be among the easiest tests that you have in your system, but they are selected with a little bit of care and thought to verify the boundaries of our domain.
Yeah, so let's summarize.
Yeah. First, a note on complexity. When we do security reviews, we usually find more vulnerabilities in more complex systems compared to simple systems. And we feel that's not just because of the size of the system, where more functionality would give us a larger attack surface, but also because it's difficult for a team to keep a system secure over time that they do not fully understand.
Yeah, and many of the vulnerabilities that we find originates from unclear, non-functional requirements and missing test cases, allowing an attacker to break out the boundaries and abuse the application. So you can't secure what you don't understand.
Yeah. So we strongly believe that tests will help you understand and identify these boundaries. And we think that automated tests will make sure that your rules and defenses are applied and implemented correctly. And we feel that this is absolutely vital for security.
Yeah, and the things that we have showed there isn't that hard to do. Security is hard, but the things we have showed isn't that hard to do. And so if all teams wrote those kind of tests, then we as pen testers would have a much harder job. And the bar for the attacker has risen significantly.
So with this presentation, we hope to have inspired some of you to perhaps do more tests with focus on security. Maybe start with a few system tests that tries the endpoints with an anonymous call. Maybe even run those tests against the production environment. Yeah. So, but will this really scale? Wasn't that a lot of tests for such a small API?
Yeah, it's just one endpoint. Then there was a lot of tests, but as always, our investment in security should be proportional to our business. And based on our experience, the things we have shown here with all the tests are a reasonable level of security for many businesses. Yeah. Really, no APIs should have vulnerabilities from the OWASP top 10 list.
No. These and many other important patterns are described in this book, written by our colleagues, Dan and the Daniels. And you might have seen them present here earlier today.
Yeah, and it's a great book, which we recommend. And if you don't feel like reading the book, then Erland Oftedal held a great Back to Basics presentation on NDC Security last year, demonstrating some of these concepts, which we also recommend watching on YouTube.
Yeah. So if you want to have a closer look at the code that we presented here today, these are the GitHub repository. Please take a look and have a play around. And I think that was all from us. Thanks.
Yes, thank you.
If you have any questions, feel free to speak up. Yeah.
What's your stance on testing in production?
So, what do we feel about testing in production? We like it. You need to be a little bit careful what you do to your production environment. And any test that doesn't require authentication is a great candidate for running against production. As soon as you require authentication, you need to think about what you're doing. That means that there is authentication for production environment somewhere in your CDCI pipeline in some way. You can do that, but you need to pay a little bit attention to the details.
So the liveness endpoint, we will typically like to do towards production because it's there in the production environment that availability is important. The test environment isn't that useful in that way.
Yeah.
And we should also test that we don't have anonymous access by passing invalid tokens and so on. We also could do that. But as soon as we succeed in authenticating, then we need to be careful. But,
so system test against production is hugely valuable, of course.
So, and if you want to reach the ready endpoint, for instance, or the error endpoint, then you should use a dedicated test client with very limited permissions to just do exactly those things. So you need to be a little bit careful. But yeah, you need tests in production because.
Yeah.
Yes.
Yeah, sure.
What do you think about using validation or data annotations in your models to verify the input instead of having that logic in your controllers?
Yeah, so the question is to instead annotate the classes, right, for fluent annotations instead. Certainly, well, we had a little coding session here last night doing exactly that. This code here today was written for clarity and for demo purposes.
But there's also one point here that if you input validation could be simple, like the things that we showed here, but for some things that gets more complex, and that becomes domain logic, and you don't want domain logic in your application layer sort of mixed up with the web framework. So you want to keep the domain logic in the domain. So even if you use those annotation, you can do that for basic things.
Yes.
You should have complete input validation in your domain.
Yep.
So, and it's okay to validate things twice, like we did with authorization. It's the same there.
Yeah, great, thank you. Yep.
Just to think about performance. But that's often not a problem.
Yeah. Okay, great. So thank you for listening and have a safe journey home.